All right, so hopefully you're feeling confident with graphing these square root functions where you've got y equals the square root of x, right? Where the restriction in the domain was x is greater than or equal to 0. And then we did y equals the square root of x plus 4, where the restriction on the domain was still that x has to be greater than or equal to 0. Because remember, you can't take the square root of a negative number. What we're going to transition into now are some equations that look like this, where instead of the plus 2 being after you take the square root, the plus 2 is going to happen before you take the square root. So the biggest thing that is going to change is the restriction in the domain. So it's still true that you can't take the square root of a negative number, which means that this x plus 2 has to be greater than or equal to 0. So what does that mean for x? Well, if x plus 2 has to be greater than or equal to 0, then if we solve this like an inequality, we would get that x has to be greater than or equal to negative 2. Which means that instead of starting at x is greater than or equal to 0, we can put in x values that start at negative 2. If I put x equals negative 2 into the equation, I get y equals the square root of negative 2 plus 2, which is the same as the square root of 0, which is 0. So if you look at this, what's happening? Well, usually my graph was starting at 0, 0 or 0, 1 or 0, 2 or something along those lines. But now my graph's going to start at negative 2, 0. If you were to talk about this as being a transformation on the graph or a shift of the graph, you could say that my entire graph is going to go left 2. Now, normally the x values we choose are 0, 1, 4, 9 because those are the things that we take the square root of, and because they're perfect squares, we get this nice value. But all of these, before we take the square root of them, we're going to be adding 2. So what we're going to do is we're going to decrease all these values by 2 so that when we put them into the equation, we actually get the same thing. So what I mean by that is we put in, instead of 0, we put in negative 2. Instead of 1, we're going to put in negative 1. So we get y equals, when x is negative 1, then we're going to add 2. Oh, look at that. We're still taking the square root of 1, which is 1. Then we're going to put in, instead of 4, we're going to take that down by 2 and we're going to put in x is 2. Because when we put in x is 2, the equation is going to make me add 2 before I take a square root. So I'm going to still end up with the square root of 4, which is 2. And then same thing with 9. Instead of 9, I'm going to put in 7. And I end up with the square root of 7 plus 2, which is the square root of 9, which is 3. So I still get the same y pattern as I got on the original y equals the square root of x graph. If we look way back up here, remember when we put in 0, 1, 4, 9, we got 0, 1, 2, 3. But for all of these graphs that we did, instead of getting 0, 1, 2, 3 for the y's, they changed. Maybe they went up by 4. Maybe they went down by 2. Maybe they went down by 5, but they still went up in ones, right? So if you started at negative 5, it went negative 5, negative 4, negative 3, negative 2. Well, for all of these equations, we've actually changed the x value. We call this a transformation on x, so that my y values stay the same, but my x's change. So if we think about graphing this, we've got a point at negative 2, 0. We have a point at negative 1, 1. We have a point at 2, 2. And we have a point at 7, 3. And then we can connect the dots. Now, for those of you who are maybe going on to Math 60, what I want you to think about is that this is a y equals square root of x shape, right? You start at the beginning and then you go over 1 up 1, over 4 up 2, over 9 up 3, but it's starting shifted left 2. So if you're someone who can understand that, you might not even need the table of values. Maybe you just know that this graph is going to start at negative 2, 0 and then have that shape of a y equals square root x graph. The domain of this graph is going to be negative 2 to infinity. So the domain always matches your restrictions in your domain, and the range for this one is going to go 0 to infinity. All right, let's try another one. So what about this one? What if we had y equals the square root of x minus 3? The first thing we want to look at is the restrictions in the domain. So again, you can't take the square root of a negative number, so x minus 3 has to be greater than or equal to 0, which if we solve this algebraically, we're going to add 3 to both sides, and we end up that x has to be greater than or equal to 3. So that means my table of values, instead of starting at 0, is going to start at 3. What's happening here? Well, I've added 3 to all the x values. Why? Well, because when I put this into the equation, when I put in x is 3, the equation's going to make me subtract 3. So to get 0, I had to actually increase my x value by 3 to counteract the subtracting 3. It always sounds so confusing, and I laugh when I say it because I'm like, does anybody know what I'm saying? But really what we're doing is we're still doing that pattern of 0, 1, whoops, 4, and 9, but to all of these x values, we're going to increase them by 3. Why? Because when I put them into the equation, now I've got 4 minus 3. Oh, there's that square root of 1, which is 1. When I put in 7, I have to 7 minus 3. That's the square root of 4, which is still that 2. Can you guess what's coming next? Hopefully you know it's going to be a 3. And let's double check it. When I plug in x is 12, 12 minus 3, oh look at that, it's 9. And that gives me 3. So I get the same shape, but instead of starting at 0, 0, I'm going to start at 3, 0. I'm going to go maybe over 1 up 1, over 4 up 2, over 9 up 3, or just plot your points. I've got a point at 4, 1. I've got a point at 7, 2, and then this grid won't let me fit 12, 3. I think in the homework assignments or assessments that I made, or questions, I just changed the grid so that you could fit them. But you know, if you can only fit 3 points, you can only fit 3 points, and that's okay. So for this one, my domain is going to be 3 to infinity, and my range is going to be 0 to infinity. All right, hopefully you understand where I'm going with this, and I want you to try this one. So pause the video and give this one a go. So for this one, when we're talking about restrictions in the domain, you have to take the square root of a positive number, so x plus 5 has to be greater than 0. I'm going to minus 5 from each side, so x has to be greater than or equal to negative 5, which means my table of values is going to start at negative 5, 0. If you want to double check that, right, let's plug in x is negative 5. Negative 5 plus 5 is the square root of 0. Oh, look at that, it's 0. So what have we done to our x values? Well, normally it's 0, 1, 4, 9, but we're having to minus 5 from all of them. So we're going to go minus 4, we're going to go minus 1, and we're going to go 4. And then let's double check what happens when we plug those into our equation. So when I plug in negative 4, I get negative 4 plus 5, which is the square root of 1, which is 1. Yay, I'm predicting 1, 2, 3, right? And when we plug in negative 1, I've got negative 1 plus 5, which is the square root of 4, which is 2. And then lastly, I've got 4. The square root of 4 plus 5 is the same as the square root of 9, which is 3. So now I'm going to graph this starting at negative 5, 0, and then either do your shape or plot your points. So negative 4, 1, negative 1, 2, and 4, 3. Awesome. This one's going to have a domain of negative 5 to infinity, and it's going to have a range of 0 to infinity. So for all of these graphs where the transformation, I'm going to call it, or the number, is in underneath the radical sign with the x, it's a transformation on x. So this one went left 5, whereas this one up here, the graph went right 3. And if you want this sort of proof to yourself, Desmos is an awesome tool. I was making your worksheet and your answer key here. Let me just delete these. So if you go and you kind of just play with this, right? Just to really emphasize this, you've got y equals the square root of x, okay? That's your base shape. If I plug in y equals the square root of x plus 5, so if I put the plus not underneath the radical sign, what's going to happen to the graph? Well, you're taking the square root and then you're adding 5. So this is a transformation on y. This is going to make my graph go up. There we go. If I did the same thing, but instead of putting plus 5, I put minus 5, the graph goes down. Because you take that square root, so your x values don't change. You use 0, 1, 4, 9. But then after you take the square root, this plus 5 or this minus 5 is happening. If instead of that transformation being on the end, I put it in with the bracket, then it's a transformation on x, because you have to change your x values so that when you take the square root, you get these nice y values. So if I put a plus 5 under here, it makes it go left. And the reason it's opposite as it looks, think about your domain restriction. You have to take the square root of a positive number, or 0. So x plus 5 has to be greater than or equal to 0, which means x has to be greater than or equal to negative 5. Right? Your x values have to be decreased by 5 because the equation is making you add 5. Whereas if I did this as a minus 5, I could say that this graph went right because I had to increase my x values by 5 so that when it subtracted 5, they stayed the same. Now that can all be very confusing. The key thing I'll say just to summarize is that when you're making your table of values, for y equals square root of x, choose 0, 1, 4, 9. Right? For all these top 3, choose 0, 1, 4, and 9. Whereas if there's something under the bracket with x, make that greater than or equal to 0 and look to see where you're going to start. So for this one here, I'm going to start at negative 5, right? So if I choose negative 5 to start, and then use that pattern 0, 1, 4, 9, okay? So from negative 5, go up 1 to negative 4. From negative 4, go up, or from negative 5, 0, 1, 4. So I'm going to go up 4 to negative 1. I don't prefer this way. I like doing the 0, 1, 4, 9 on the side and then subtracting 5 from all of them. So 0, 1, 4, 9 minus 5 would be 4. And then you get these really nice points. Awesome. Okay, hopefully you're feeling good with that, because then the next thing we're going to do is do these with cubed root graphs.